My name is Lin Hui. This is our good report. The title is The Application of Linkage Interpolation for Polynomial Method and Newton Dividend Difference Interpolations Method in Civil Engineering area. We are in group 1. Other member is Lau Jianping, Muhammad Ridwan bin Pir Muhammad, Muhammad Akmal bin Sarukaram, and India Hani Bidi Basaram.
Introduction. Polynomials are used as the basic means of interpolation in many areas of engineering, largely because of their simplicity. And sometimes the most simple and obvious of methods give results that are unreliable or even catastrophically wrong for practical problems. Our project shows that a method previously published in the civil engineering transaction is liable to accuracy, notably for problems in the lag area. There are two types of interpolation. First one is Lagrange interpolation. The Lagrange interpolation formula is a method for determining a polynomial that takes on specific values at random places. Number two is Newton's divided difference. Newton divided difference interpolation formula is an interpolation technique used when the interval difference is not same for all sequence of values. Next is problem statement. First is approximating, predicting, and estimating some unknown information in a catch base of the length. Number two is how to compute the interpolation formula on the survey area. And the last one is how accurate the difference of temperature is by using Lagrange interpolation and Newton's divided difference.
Assalamualaikum and greetings to everyone. My name is Muhammad Ridwan bin Muhammad. My metric number is CF200236. Today I want to explain about objective of this project. The first objective is determine which data might exist outside of the collected data by the lake area. The second is to apply the interpolation method or technique at the lake with the civil engineering method. The third objective is to construct new data point within the range of the discrete set of known data points. Okay, this is the filler table. The first fact is interpolation has been used in one form or another for just about every purpose under the sun. So the idea is we use Newton divided differential method and Lagrange interpolation. The issue is how to use in civil engineering area. So the action we do research about interpolation and connecting with the civil engineering method. So the second fact is in order to explain the application of numerical method using the Newton divided differential in real engineering problems, the proposed statement was developed. So the idea we get is formula. There are a lot of formulas, so we have to refer to the notes. And the issue is how to get Newton divided differential interpolation and Lagrange interpolation polynomial wolf. So the action is search for information and data through the internet. So the third fact is knowing the advantage and disadvantage of Newton divided differential interpolation method and Lagrange interpolation polynomial method. So the idea is how to use the method in real life. So the issue we use is the learning the advantage and disadvantage of the method, and the action research and information about the advantage and disadvantage of the method.
For the literature review, said Sir Edmund Whittaker, a professor of numerical mathematics at the University of Edinburgh, the most typical sort of interpolation happens when we seek data from a table that does not include the exact numbers we desire. The interpolation has been employed in some form or another for almost every function under the sun throughout history. As mentioned at the slide, there is a story of interpolation.
Salam sejahtera, my name is Lau Jianping and I will going to present my part. Language interpolation polynomials, and there are 4 advantages and 1 advantage, and I will going to mention 1 advantage. Used in simultaneous optimization of norm of derivative or language interpolation polynomials, and the disadvantage is it becomes a tedious job to do when the polynomial order increase, the number of the points increase. There are 2 advantages for the Newton divided. And the first one is the use of nest multiplication. In general form, language interpolating polynomials is given by this formula. Linear approximation the degree 1 P1s that passes through the two given points. And this is the formula, and you can refer on this one. Quadratic approximation is the passes through 3 points S0 F S0, S1 F S1, and S2 F S2. And this is the formula for the quadratic approximation. Cubic approximation is that passes through 4 points S0 F S0, S1 F S1, S2 F S2, and S3 F S3. And this is the formula. For the Newton divided differences, consider the given set of the data S0 F0, S1 F1, Sn Fn. And this is the formula for the Newton divided. The first Newton divided, second Newton divided differences, and the third Newton divided differences have each of the formula, and you can refer on this one.
My name is Muhammad Akmal bin Shah Al-Kalam. I want to present the results of calculation of Lagrange interpolation polynomial. So the first one we want to solve in linear approximation, which is the first order. So we substitute the value of depth and temperature for negative 7 meter and negative 8 meter into the first order interpolation formula. So we got 14.65 degree Celsius. The second one we want to solve in quadratic approximation, which is second order. So we substitute the value of depth and temperature for negative 7, negative 8 and negative 9 into second order interpolation formula. So we got 14.137 degrees Celsius. The absolute relative approximation error between the first order and second order, we got 3.63%. The last one for Lagrange interpolation polynomial, we want to solve in cubic approximation, which is third order. So we substitute the value of depth and temperature for negative 6, negative 7, negative 8 and negative 9 into the third order interpolation formula. So we got 14.725 degrees Celsius. The absolute relative approximation error between quadratic approximation and cubic approximation is 3.99%. That's all from me. Thank you.
Calculation of Newton divided difference interpolations. We have the formula for F0 bracket 1 equals to F1 bracket 0 minus F0 bracket 0 over X1 minus X0. For other formula also same. So using this formula, we can get the first Newton dividend difference, second Newton dividend difference, and third Newton dividend difference. Hence, Fx equals to P3x. We substitute the dip, temperature, first Newton dividend difference, second Newton dividend difference, and the third Newton dividend difference. We can get the answer is 14.725 Celsius. For the discussions, using the Lagrange interpolations, the absolute relative approximate error is 3.63 for linear and quarantine interpolations and 3.99 for quarantine and cubic interpolations. Newton divided difference interpolation method does not have an absolute relative approximate error. Using Newton divided difference interpolation method to calculate more easy and need less time compared with the Lagrange interpolations. Difficult to check back the answer if discover the answer is wrong when using the Lagrange interpolation. So we can do the conclusions. The Lagrange interpolations polynomial method and Newton divided difference interpolation method can be applied in the civil engineering area. Both methods can find the same result, which is 14.725 Celsius. The best method we think to calculate is the Newton divided difference interpolation method. This is because this is more easier to get an answer. Thank you.